Hello, discrete math students. There we go. Okay. So yeah, here's another tutorial video for you. In this video, I'm going to try to cover a little bit of Mathematica, a little bit of Racket, and a little bit of Python. All right. And as an example, just as an example, we're going to talk about the problem of partial sums. So what are partial sums? Okay, so consider, it's really not that hard. Consider you have a sequence of numbers, like a sequence of integers. Let's just stay with integers for right now. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, so what are partial sums? Well, we start with the number 1. 1 plus 2 is 3. 3 plus 3 is 6. 6 plus 4 is 10. 10 plus 5 is 15. Excuse me, 15. 10 plus 5 is 15. 15 plus 6 is 21. 21 plus 7 is 28. And 28 plus 8 is 36. And 36 plus 9 is 45. And then 45 plus 10 is 55. Okay, so we could call this my list of partial sums, my sequence of partial sums. Okay, it's not that hard, right? But this gives us an opportunity to kind of play around with lists in Mathematica, in Python, and also in Racket. So yeah, and it's not that big a deal, right? So partial, let's see if I can write this with my trackpad. Oy. I usually write better than this, but okay, partial. Okay, partial sums. Okay, the list of partial sums. Okay, and we're going to do this in Mathematica, we're going to do it in Python, and we're going to do it in Racket. All right. Okay, so here's Mathematica, but the font is way too small. Way too small. I can't even see what the hell I'm doing. So I'm going to click on Format, Edit Style Sheet, select Input, and select Output. I'm on a Mac, so if I do Command B, that's going to change the output to bold, which is nice. That's what I want anyway. Click on Format, Show Fonts. Okay. No, that's really a little too big. So how about, I don't know, 28. And we could do the same thing for output, 28 pixels. Okay, let me change the font a little bit. Crazy about Arial. So Arial is a nice font. I like Arial. Okay. Change that to Midnight Blue. And change that to, I'm going to change that to Plum. And we are all ready to go. Okay, so it looks like, everything is pretty good. Let's see. I'm going to write a comment in Mathematica. How do I write a comment? Well, open parens times close paren. And actually, I'd like to change that coloring a little bit. I'm not crazy about that coloring. So help, why the coloring? See the preferences dialog for more syntax coloring options. Okay, so let me see. Syntax coloring. Yeah, comments. So let's change this one. Comments. Let me see. How about grape or magenta? Make that a little darker. There we go. Okay. That looks good. Okay, so it should be, wish that was bold, but that's okay. We can worry about that another time. Okay, so for this project, we are going to work on the problem of partial sums. Oh, you know, when you're, yeah, Mathematica has an issue with commas sometimes. So I'm just going to omit the comma. For this project, we are going to work on the problem of partial sums, which is similar to some of the problems that you will encounter in chapter 2 of your textbook. There we go. Okay. Oh, you know what? I really should. Well, I just want to see something here. One moment. Wish I could make that bold. There's a way to do that, but I think I forgot how to do that, but that's okay. That's okay. Okay, that's good enough. I mean, if I want to make it bold, I'm pretty sure I could do something like this. Format, option inspector, selection, you know, font, and no, format, wait a second. Yeah, it's a little weird. So what if I just do this? Format, face, it is bold. How strange. That doesn't look bold to me. Well, that's fine. Whatever. Okay. So size. Oh, sorry. Face. It says it's bold. Bold. Oh well, that's okay. Not really. It's a cosmetic issue. So I'd like to make the font bold, but that's okay. Okay. So let's get to this. So in Mathematica, we could do something like this. Table K, where K goes from 0 to, I don't know, let's say 10. And of course, at the end of each line, you press Shift, hold down the Shift key, and then press Enter. All right, so depress Shift plus Enter. Okay. And then I have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That looks terrific, right? So there are different ways of doing this problem. One possibility is to embed, you could have two nested calls to the table function. You could have two nested calls to the table function. So although that's not the most efficient way to solve this problem, but it is one way to solve this problem. All right, so for example, table, it doesn't have to be K. Choose choose any variable name that you like. A, B, C, X, Y, Z, K, M, N, whatever letter you like. Whatever letter you like, okay? So K goes from 0 up to another variable. Another variable, I'm going to call it M. All right. Table, M will go from 0 to 10. So now I see that, now remember, these are my two nested table calls. All right, so I have 0, 0, 1, 0, 1, 2, 0, 1, 2, 3, 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, 5, and then, 0, 1, 2, 3, 4, 5, 6. You get the idea, okay? You get the idea. You can see what I did, right? Okay, the other well, you could use for loops, but then you're gonna make the problem more difficult. You could use for loops, but I guarantee if you do that, the problem does become a lot more complicated. So let's try to keep things simple, okay? Let's try to keep things simple. So then what I have to do is I have to add up, okay, all the numbers in this list, so just 0. 0 plus 1 is 1, easy. 0 plus 1 plus 2 is 3. And 0 plus 1 plus 2 plus 3 is 6. And then 0 plus 1 plus 2 plus 3 plus 4 is 10. And blah, 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 blah. You get the idea. No, it's easy. So for this, what I'm going to do is, it's called a mapping. It's called a mapping. So I'm going to define this function, right? Now, what if I do this? What if I do plus 1, 2, 3, 4? Okay, well, that was easy. So I'm applying the plus function to the list 1, 2, 3, 4. So 1 plus 2 is 3, 3 plus 3 is 6, and 6 plus 4 is 10. So if I apply the plus function to this list, then I end up, adding up all the numbers, all the integers of my list. So all I have to do is apply this function to every sublist here. So why don't we do that, okay? Plus, this is going to be my anonymous function. This is a placeholder. It's kind of like a variable. It just means, the hash symbol means, some argument. Some argument. And in this case, some argument refers to each sublist. All right. So add up, all the integers of each list, map that. That's the symbol for mapping. And I'm just going to copy what I have here. Sorry. Yay. Come on. Wait a minute. What am I doing here? Okay. Table K0M and 0, 10. Oh, and I shouldn't forget this. Whenever you have an anonymous function with a this is called an anonymous function. This part right over here, whenever you have an anonymous function, you have to close it with the ampersand symbol and then shift enter. Well, what do you know? I've got 0, 1, 3, 6, 10, 15, 21, 28, 36, 45, 55. Okay, that was good and easy, right? Not a big deal. That was very easy. So in general, what I could do, I could make a function. Well, I could start with 0 or I could start with 1. It doesn't really make a difference. It depends on the specifications of the problem. It depends on the specifications of whatever problem you happen to be working on. We could start with 0, we could start with 1, your choice, right? Or the choice of the person who wrote the mathematics problem, or the programming problem. Discrete math is interesting because discrete math, in a lot of ways, this is a math course, but in a lot of ways, it's a computer science course. I mean, it could go either way. You know, it's like mathematics for nurses. That's kind of, you know, a math course, but it's kind of a biology course. Calculus 3 is kind of like that. The vector calculus course. A lot of it is math, but sometimes in that course, you know, you're studying a lot of physics because vector calculus is used a lot in physics. Finite math is another course that's like that. Most of the students who take finite math are business majors. So officially, it's a math course, but in a lot of ways, it's kind of a business course because a lot of the application problems in that course are related specifically to business. So this course is kind of a hybrid. It's a math course, but a lot of the material in this course is very specifically related to computer science. And in fact, a lot of the students who take this course are computer science or computer engineering majors. So that's one reason why I put a big emphasis on programming when I teach this course. And why not? Programming is so much fun anyway. It's a lot of fun. It's a fun way to learn math. It's a very fun way to learn math. So let's make a function out of this. Let's turn this into a function. Okay. So I'm going to call it partial sums. Now, just a word to the wise guys: when you create your own Mathematica functions, you don't have to, but I strongly recommend that you start with a lowercase letter. And the reason why is because all of Mathematica's built-in functions start with a capital letter. So it's good practice to make sure that the user-defined functions, the functions that you create for yourself, they should begin with a lowercase letter so that you can distinguish them from Mathematica's built-in functions, okay? Okay, partial sums. What would be a good, well, let me see here. Hold on one second. Okay. Yeah, I'm just gonna, okay. I'm trying to think of something kind of complicated here, but that's okay. So partial sums, and now one moment. If I just want to provide the arguments without the list form, no, I'll make it simple. I'm trying to get too complicated here. Okay, so partial sums. I'm going to have some list that I'm going to provide. I'm going to have some. Now you need that underscore. That single underscore tells me that I'm providing one argument. And the argument in this case is going to be a list. The argument in this case is going to be a list. We'll get to this a little bit later on, but if you have 2 underscores, that means something else. If you have 3 underscores, that means something else. But 1 underscore means you're providing one argument, and in this case, my argument is going to be a list. Whatever you do, please do not use capital L, because capital L list, that means something very specific in Mathematica, okay? So then we're going to simply do, let's see, I'm going to skip over to the next line to make it more readable. I'm basically just going to copy what I have here. Well, let me see here, but I'm assuming I'm starting with 0, and I'm not necessarily starting with 0. So I'm going to create a module. What is the first value of my list? The first value of my list is going to be the, oh, wait a minute. Oh, that's cool that the new version of Mathematica does that automatically. Okay. You're going to use double brackets. That means, you know, the first element of my list. The first element of my list, okay? So And then I'm going to copy what I have above. Almost. Almost. But the initial value of k is going to be first instead of 0. And the initial value of m is going to be first. Oh, but we do have an issue here. The only problem would be we're not going up to 10. We don't know. Oh, let me think. Well, I'm going to assume. See, this is okay. So this one moment. I'm going to assume that what I have is something like this, where everything is the difference between successive integers is 1, although that's a big assumption, but let's assume that. Let's assume you have a list like, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or whatever, and I'm assuming here that 2 is going to be 1 plus 1, and 3 is 2 plus 1, is 4, 4 is 3 plus 1. So each successive term is going to be 1 greater than the previous term. But then if I'm assuming that, hold on just one second. If I'm assuming that, why do I need to even provide the list? See, let me rethink this a moment. It would make more sense. Okay, it would make more sense to have start, stop, and step. Well, for right now, let's assume the step is 1. And we can change that. We can change that later on. So this makes more sense. Okay. So what I could do here would be plus table. We're going to start with, start m. M goes from start to stop. Let's see if this works. Partial sums 110. Yeah. Partial sums 010. Okay. Partial sums 0, 100. Okay. It looks good. So yeah, 50 right over here, you have 55, right? What's 55 plus 11? 55 plus 11 is going to be the next number, which is going to be 66. And then you have 66 plus 12. What's 66 plus 12? 66 plus 12 is going to be 78. And so on and so forth. Okay, now if you're going to provide a step, if you want to do that, if you want to make this function a little more interesting, k goes from start to m. What you could do, I'm making the problem a little bit harder, but that's okay. K goes from start to m. M goes from... You could put in a step right over here, and now the step doesn't have to be 1 anymore. Okay, so shift enter. Let's do this. Now the step is 2. So 0 plus 2 is 2. 2 plus 4 is 6. 6 plus 6 is 12. 12 plus 8 is 20. 20 plus 10 is 30. So now we're going in steps of 2. Okay, we're going in steps of 2. Although this one should not... There seems to be a default value thing going on over here. Hold on 1 second. So clear partial sums. And let's define that again. Okay. Right, so this time it's not working because the function expects a third argument. The function expects a third argument, so it's not working now, okay? So what does the third argument do? Well, you're going to have this list, right? You're going from 0 to 10 in steps of 2. You've got 0, 2, 4, 0, 2, 4, 6, 8, and 10. Okay, you start with 0. 0 plus 2 is 2. 0 plus 2 plus 4, well, we know that's going to be 6. 6 plus 6 is 12. 12 plus 8 is 20. 20 plus 10 is 30. Oh, sorry about that. Okay, so this time it's not going to work if you only provide 2 arguments. You need to provide 3 arguments, right? Okay, so same thing here. You know, this one won't work, right? But it will work if I provide that step. It will work if I provide the step. Now, what if the step is fractional like that? It should still be okay. It should still work. Okay, so 0 plus 0.5, you know, and then you have, so this is a little harder to reason about. So you're going in steps of 0.5, so that means you're going to have 0, 0.5, and then you have 1, and then you have 1.5, okay? So you start with 0, 0 plus 0.5 is 0.5, and 0.5 plus 1 is, or 1.0 is 1.5, and then, and then 1.5 plus 1.5 is going to be 3. You know, you get the idea. Okay, so, oops, wait a minute, what did I just do? Hold on a second. Oh, there we go. Okay. So that's our partial sums function. So partial sums 1 to 10 in steps of 1 gives me that list. And that's what we did originally, right? That's what we did, you know, at the beginning of the video. Partial sums from 1 to 10 in steps of 1. But it could be, you know, partial sums 0 to 100 in steps of 25. So 0 and then 25. Okay, and the next number in the sequence is 50. So 0 plus 25 plus 50 is 75, right? So here you have the list 0, 25, 50, 75, and you have 100. Okay, well, 0 plus 25 is 25, and then 25 plus 50 is 75, and 75, 25 plus 50 is 75, and then 75 plus 75 is 150, and then finally, if you add 100, you get 250. So we have 0, 0 plus 25 is 25, 25 plus 50 is 75, 75 plus 75 is 150, and 150 plus 100 is 250. Kind of cool, huh? So yeah, I mean, there's all kinds of stuff you can do with Mathematica. It's got its own programming language, and it's actually pretty cool. It's just a lot of cool stuff you can do with it. Although I would like to figure out how to make that bold. That's really kind of annoying. Let me see. I should probably mess with this after the video. Let me see. Option inspector. One second. I don't want to take up too much video time with this. So, Oh, comments. Oh, you know what? I think, okay, hold on. I think I know what to do. We're going to go into Option Inspector, Global Preferences, Comments. Ah, comment style. Yes, 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 yes. And okay, oh, come on. Font weights. Here we go. Font weight. Oh, no. Font weight should be bold because that's what I prefer. Bold. There we go. Wonderful. Okay. Sweet. And I made it a global preference so that when I shut down Mathematica, I'm still going to have the same preferences when I start up Mathematica again. Okay, so very sweet. Okay, I like bold font. All right, so that's that's kind of cool, right? Okay, so we did that. Now how about Python? How will we do the same thing in Python? So we don't need to save this. Oh, hold on one second. Don't turn the sound on, okay? Because I'm still making a video. Okay, so let's see. Terminal. Let's see. I'm going to use a Jupyter notebook. This time I'm going to use Python inside a Jupyter notebook. Okay, so Jupyter notebook. Okay, so new Python 3. Please use Python 3 for this course, guys. We're not going to use Python 2, okay? Here, hold on one second. Let me just put the laptop on the desk here. Okay, so how about comments in Python? Oops, why is it doing that? This is a comment in Python. Anything that follows the hashtag. You could just use one hashtag. I like to use 3 hashtags. Just because I like the number 3, I guess. I don't know. Okay, there is dirt on my computer. Let me try to get that off. Okay. So that's a comment in Python. Okay. And I can just, shift enter, just like in Mathematica. This is a comment in Python. So what about the problem of partial sums? Well, first of all, consider this. So in Python, Python has something called a list comprehension, which is similar to Mathematica's table. So for example, list range 10, I bet you think that's going to give me all the integers from 1 to 10, but actually it won't. It'll give me the integers from 0 to 9. It's going to give me the integers from 0 to 9 because by default, we always start with 0 and we go up to one less than this number over here, okay? So if I want the integers from 1 to 10, I would have to do this. Not in Mathematica, but in Python. Okay. So how would I get that list of lists? How would I get that list of lists that I showed you in Mathematica? Well, I can use a list comprehension in order to do that. I could use a list comprehension. So we could do something like this. Let's see. List range 1 to x. I'm just using x as a placeholder variable for x. And actually, I've got to be careful here. I should really, for x in range 1 to to, let's say, some limit, which is going to be, let's say I want to go up to 15. This is going to have to be 16. If I want to stop at 15, that it's going to have to be 16. And this will actually have to be x plus 1. Let's see what that gives us. Okay, so that gives me 1, 1, 2, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4, 5, 6, 7. You get the idea. So we have sublists, sublists. I'm using the word sublist. I'm using the word sublist. Oops. I'm using the word sublist. Okay, so these are sublists, and in each case we are starting with 1. Here's the 1. Okay, here's the 1. And then I am going up to 15, but in order to do that, this upper limit has to be 16, and this upper limit has to be x plus 1. All right? Actually, in Racket, it's the same thing. Racket ranges are very similar to Python ranges. It's the same thing. Okay, so again, 1, 1, 2, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5, and then we have finally 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, okay? So what if I want to add these up? I want to add these up, okay? So what I would have to do is write a function that is applied to each individual sublist. So that becomes a separate problem. How would I do that in Python? I'm just thinking about something in Racket, but okay, hold on one second. I'm distracted. I'm thinking about Racket for a moment. So I remember how to write a multi-line comment in Racket. I'm trying to remember, I think the hashtag is used for the single line comment as well. Well, we'll figure it out when we open up Dr. Racket. Okay, so I'm going to write my sum. Actually, you know what? I think Python has a built-in sum function. Sum 1, 2, 3. Whoops, Shift Enter. Yeah, but let's write our own function, okay? I'm not going to use Python's built-in function. I want to add my own. I want to define my own function. So define, oh yeah, sorry, that's Racket. Define add up list, and I'm going to have some list. Okay, and if, now this is important, okay, before I even do that, let me show you something. What happens if you change the empty list into a Boolean? If you change an empty list or empty dictionary or empty anything, if you have an empty collection in Python and you change it into a Boolean, it's always going to be false. Okay, so if I have a list that's not empty and I change it into a Boolean, it's going to be true. But if I change an empty list into a Boolean expression, it's going to be false. Remember that Booleans are true or false. They're either true or they're false, okay? Those are the only two values of the Boolean type. It's either true or false. So, and false is, similar. It's related. It's like the number 0 and the number 1, okay? So true would be 1 and then false would be 0, okay? So we can actually use this. Now, here's what I'm going to do. So define add up list. And I'm going to call, well, we could just call it x's, where each number is an x. A list of x's, where each number is an x. And the first, remember, this Python is 0 indexed. So the first element of the list is x is 0. I'm going to call that first. The rest of the list, why is this doing that? Okay. The rest of the list is 1 colon. All right, so in case you're wondering what that does, hold on just one second. Oh, here we go. Insert cell above. Okay, so let's say I have a list. 1, 2, 3, 4, 5. Oh, what am I doing? That's not, that's a dictionary. Okay, so 1, 2, 3, 4, 5. Shift Enter. And insert cell above. Okay. My list 0 should be the number 1 because it's the first element of the list, right? And then, insert cell above. What if I have my list 1 colon? That's going to be the rest of the list, which is 2, 3, 4, 5. If you keep that up, you'll eventually go down to the empty list. So for example, what if I do that again? 3, 4, 5. What if I do that again? 4, 5. What if I do that again? Oh, 1 second. 5. What if I do that again? Now I'm going to have an empty list. And once you reach the empty list, you're done. Okay, you're done. So the first element is x's 0. Okay, the rest of the list is x's 1. And actually, even before that, I have to test if the list is empty. So if Boolean x's, now remember, if the empty list is changed into a bool, it's going to give me false. So I want this to be true, make it the opposite. So if the list is empty, if my list is empty, return 0. Else, okay, these have to be white space. These have to be tabbed over. So Python reads white space, okay? And then I'm going to do return first plus add up list the rest of my list. So let's see if this works. Add up list 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It should be 55, right? And it's 55. So if I have an empty list, this just gives me 0. Add up list 1, 2, 3. So 1 plus 2 is 3 plus 3 is 6. That should return 6. Okay? So this function is recursive, and the reason why it's recursive is because it calls itself. Right over here. This is the recursive call. That's the recursive call. Recursive, wait a minute. I'm going to spell this out. Recursive call. Okay. Oh, 1 second. There we go. Okay, so it's a recursive function. It's a recursive function, okay? So we're going to apply, we have to map this function onto these sublists, okay? So let's make it simple. Let's assume that we're just going in steps of 1. So, 1 up to whatever number. I'm not going to worry about a step this time. I'm not going to worry about a step because we're slowly running out of time. The video is getting kind of long. So I'm not going to worry about a step size. I'm just going to assume that the step size is 1. We have a default value of 1. So then how would I do this? Okay, well, let's see. I'm going to copy this. Copy and paste. Copy, paste. Okay, so, but of course we don't have to end at 16. So I'm going to have a function, call it partial sums, and let's assume we start with the number 1. So we're going to have an upper limit, upper, and this is going to have to change. We may not want to end at 15. We may want to end at some other value. So let's change that to upper. Let's store this in a variable that's specific to the function. What should I call that? My list. Okay, and don't worry, it will not conflict with this my list because this my list is global and this my list exists only when this function is run. Okay, and this should actually be upper plus 1. Sorry, upper plus 1. And then we're going to do map add up list to my list. And we're going to change that into a list because the map function returns a generator in Python. We could talk about that some other time. So, and this is what I'm going to return. Shift enter. Let's see if this works. Partial sums 50. Well, let's just go up to 10. Okay, that looks great. So 1 plus 2 is 3, and 3 plus 3 is 6, and 6 plus 4 is 10. 10 plus 5 is 15. 15 plus 6 is 21. 21 plus 7 is 28. 21 plus 8, we have 36. 36 plus 9, we have 45. And 45 plus 10 is 55. How about partial sums 100? Well, that we could, yeah, hold on. Let me turn pretty printing off because sometimes that's kind of annoying. Pretty printing is turned off. And let's do that again. So partial sums 100. There we go. Okay, so if I add up all the integers from 1 to 100, I'm going to get this number right over here, 5,050. And that's my partial sums. Okay, that's partial sums in Python. And we could do a step here. We could actually, if I remember correctly, yeah, you could do lower upper step just like in math. Actually, let's try it. We could do lower upper step, but then this would have to change. Hold on one second. This would have to change to lower. This would be lower. This would be upper plus the step. And actually, then you would have step over here. Okay, let's redefine the function. And let's see if, okay, 100 in steps of 1. We're going to go from 1 to 100 in steps of 1. It should be the same output as before. Here, let me, oh, I can't, why can't I move my picture a little bit? Oops. Okay, so partial sums, how about 10 to 20 in steps of 1? That looks good. So 10 plus 11 is 21, and 21 plus 12 is 33, and 33 plus 13 should be, yeah, 46. And then 46 plus 14, 46 plus 14 should be 60, and 60 plus 15 is 75, and 75 plus 16 is 91, etc., etc. So it works great. How about partial sums 0 to 10 in steps of 0, in steps of 0.25? Oh, float object cannot be interpreted as an integer. Oh, you know what? Okay, the problem is, yeah. The problem is right over, I wonder, yeah, I have a feeling, let me see something. I don't. Yeah, so the problem is the range, okay, this, yeah, this cannot be, the problem is that's going to have to be an integer. So, yeah, so here if we're going in steps of 2, it's 0 plus 2, and then 2 plus 4, 6 plus 6, 12 plus 8, 20 plus 30. But the problem is, what if you want the step to be an integer? So that's, okay, Python doesn't like that. So let me see something. Range 0 to 10 in steps of 0.5. Will this work? Okay, so we're getting a type error because this number here has to be an integer. Float object cannot be interpreted as integer. But if it's an integer, we're okay. Oh, this should be 12 then. Yeah, sorry about that. Well, what you could do, if you want to use a step size that's not an integer, you could try this. Although it makes the problem a little more difficult. We could redefine partial sums. So, but this is going to get more difficult. Define partial sums. We're going to have a start. We're going to have a stop. And we're going to have an accum. The accum is initially going to be, let's say it's going to be 0. And the accumulator is initially going to be an empty list. Oh, and we have to have a stop. Sorry, a step. Okay, let me see for a moment. I hope this isn't going to get too crazy complicated. Partial sums, we have a start, we have a stop, we have a step. Accumulator, we have accum, which is our starting, value of something, 0. But then 0 gets added to start. You have accumulator, which is an empty list. This is going to be all recursion. Python's not the best language for recursion, but I love recursion, and yeah, I mean, it is really, recursion is great. Many of the algorithms in discrete math, they depend heavily on recursion. So let me see here. I don't know if we're going to get to Racket in this video. If we don't, I'll make a separate video tomorrow covering how to do this in Racket, because this video is getting a little bit long. So if start is greater than stop, return the accumulator. Else, let me see here. Return partial sums, start plus step, stop, step. The accum is replaced with accum plus start. And I really wish I could get my picture out. Oh, my picture is stuck here. Okay, there's nothing I can do about that. Well, maybe, hold on one second. Insert cell below. One more. Okay, insert cell below. Okay. Accum plus start, and then we really want to get that number into the accumulator. So start plus the accumulator. This should work. Okay, so partial sum. Oh, no. What did I just do? Okay, no. Okay, there we go. So partial sums, 1 to 10 in steps of 1. Oh, it's, what I have to, okay, actually, okay, so this is a little backwards. So accumulator plus start, there we go. I think this works great. Actually, let's use a default step size of 1. Let's use a default step size of 1, but I can change that. So partial sums 1 to 10. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Or let's say partial sums 1 to, wait a minute. Partial sums 1 to 10 in steps of 0.5. Let's see what we get. That looks good. So 1 plus 1.5. Yeah, in steps of 0.5. So if we have, okay, so let's see, we have 1 and then 1.5 right? And then 2 and 2.5, etc., etc. The only problem... Oh, you know what? This is not quite what I... Okay, now I see what the problem is. This should be... No. Okay, no, that's not... This should be accumulator plus accum. Not start. Accumulator plus accum. Let's do that over again. This should... Now, the problem here... The way I have it set up, we're always going to be starting, okay, with 0, yeah, which could be, I don't know if Python will let me do this. I have a feeling it's not going to let me do this. Yeah, it won't let me do that. Okay, so, okay, so then I would have to... accum is equal to start. And then over here, I have to remove this argument. So I told you this was going to get more complicated. And then we could update accum. Accum is equal to accum plus start. Let me see how this works. Oh, no. But now, see, now I'm getting... Wait a minute. This got kind of screwed up. Okay, hold on one second. It was a little better before, actually. You know what I'm going to do? The accum... I'm going to put this value over here. These two will have default values. The accumulator should initially be equal to start. So we're going to get rid of this line. And here we're going to do accum plus start. But yeah, that's a little crazy. Okay, so let's try that. Which means we must now, we have to provide the function with 3 arguments. The last 2 are they're default arguments. I don't have to provide them explicitly. But these 3 arguments must be provided explicitly, okay? So if we do 1, 10, 1, okay, why on earth am I getting, okay, something got terribly screwed up here. Okay, start, stop, accum, step 1, accumulator. If start is greater than stop, return the accumulator. Else, oh, of course. Okay, this doesn't, yeah, that doesn't make any sense. Okay. Otherwise return start plus step, stop. No, so the accum, okay, the accum variable should be there, and then step should be over here. Okay, let's try that again. Almost. So here we're going to have to do almost plus accum. Oh, you know what? This should initially be 0. But then, see, the problem with that... See, if I don't want 0 in my list, that's going to be an issue. I'm just tweaking this, guys. Hold on one second. Yeah, that's not quite what I want. So if I want to start my list with 1, okay, and here the accumulator is 0, accum plus start. See, the problem is here, start is equal to 0. So, I mean, that's okay, but then I'm always going to have that initial 0 at the beginning of the list. So here, for example, well, here, okay, if I start with 0, what if I start with 0.5? Yeah, see, I'm not really starting with 1, then I'm starting with, this is really the accumulator right over. I'm really starting with the accum. Start plus stop. Stop, accum plus. So this is interesting. The only. Well, this could be a work in progress, but basically you get the idea. But the thing is here, so we're starting with, yeah. So, but this isn't quite what I want. Let me see. If start is greater than stop, return the accumulator plus the accum. Return partial sum. Start plus step. Stop, accum plus start. Hey, Chach, jump up. I'm talking to my dog, guys. Sorry. Accum plus stop. But that wouldn't quite make sense. But let me experiment with this. Hold on one second. No, see, that's not going to work at all, because then I just have a regular sequence. Yeah, so that's not going to work. And, well, if we start with 0, yeah, but it's basically, no matter what, I'm always starting with my accumulator, unless, oh, you know what, there could be another way of doing this that might make a little more sense. We could define it this way, although, well, but see, okay, hold on one second. So we could do, okay, so this is going to, well, we're not going to have time for Racket today, guys. I'm going to have to do this in Racket tomorrow, but if we were to do, yeah, I'm not quite getting exactly what I want here, but that's okay. So, yeah, for the case, for the easy case, here, let me do it like this. And actually, if the accum is 0, yeah, so, and actually we could put step over here so it no longer has a default value of 1. Hold on one second. So here we would have, okay, one second. Let me redefine that. Okay, so, whoa, what's going on here? Start plus step. Stop, accum plus start, and then stop accumulator plus accum. Okay, so I'm really kind of botching this up a little bit. I'm getting some really interesting stuff here. So, Okay, so basically, I'm trying to make this a little too complicated here. So this is, I can't quite get the subtlety that I want, but that's okay. So let me delete dd, delete dd, delete dd. Okay, wait up. Okay, so here, this function works really well for the simple case where the step is equal to 1. If the step is not equal to 1, then you have a little more work to figure out. Let me just copy and paste this. Copy, paste. Okay, so this function works pretty well if you have partial sums 1, 10, steps of 1. Okay, or partial sums 0, 10, steps of 1. But here, the problem with this one, no, that works fine too. So as long as this value is not a float, this function actually works really well. So the original function that I had, the original function that I wrote, it works pretty well. So partial sums 100 and steps of 1. Okay, so that works great. We start with the number 1. 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, 10 plus 5 is 15, 15 plus 6 is 21, 21 plus 7 is 28. And finally, you have 5,050, which is the sum of the first, hey Chachki, the sum of the first 100 integers from 1 to 100, okay? What happens if we do partial sums 0, 100, and steps of 1? Same thing, except this time we start with 0 instead of 1. Partial sums 0, 100, and steps of 2. So that works well. 0, and then 0 plus 2 is 2, and 2 plus 4 is 6, and 6 plus 6 is 12, and 12 plus 8 is 20, and 20 plus 10 is 30, 30 plus 12 is 42, and 42 plus 14, that gives us 56, and 56 plus 16, so that's going to give us 72, and then 72 plus 18 gives us 90, and so 72 plus 18 gives us 90, and then 90 plus 20 gives us 110, plus 22, 132, etc., etc. So this function works great. The reason I tried to rewrite it, and I got myself into some trouble there, I tried to rewrite it because I wanted to write a function that would accept a fractional step. Okay, I wanted to write a function that would accept a fractional step, a float value, a floating point value for the step. Unfortunately, Python has an issue with that. Python has a little bit of an issue with that. So we would have to modify the range function. I'm wondering if we could do that. So if you're going to define my range, start, stop, and step, and you start out with an accumulator, which is a list, okay, and while, now the problem is, I want to just see something, and I want to see if we can do this in Python. Start is equal to start plus 2, return start. Okay, I'm just doing a little experiment. My range 6. Okay, so Python does allow us to mutate the arguments to a list. Okay, so start, stop, step. Okay, let's see if we can do that. While start is less than or equal to stop. 1 second. Accumulator is an empty list. And we are going to have accumulator is equal to accumulator plus start. Start is equal to start plus step. So while the start is less than or equal to stop, actually maybe I should make that step. Stop plus step. The accumulator is equal to accumulator plus start. Start is equal to start plus step. And then at the very end, we're going to return the accumulator. Let's see if this works. My range 0, 10, 1. Zero up to 11, so we should really maybe change that. That works great. My range 0, 10, 0 0.5. 0, 0 0.5, 1, 1. Okay, that works terrific. My range 0, 12, 0 0.6. Right. Because this makes a lot of sense, because if you take the range of integers from 0 to 12 and you try to divide it up into equal chunks of length 0 0.6, it doesn't 0.6 doesn't divide evenly into 12 minus 0. So that's why you're going to have like these weird decimal answers. Okay, but it looks like it's really working out good. This is 11.99999. It's almost 12. This is like 11.3. This is 11.4 basically. You'd have to round out. You'd have to round everything out. So yeah, don't worry about it. It's working just fine. So my range 0 to 10 in steps of 0.2. And again, you have a lot of round off error that's going on. So 0, 0.2, 0.4, 0.6. This is a computer issue. This is not a Mr. Lewitt issue or a Python issue. It's a computer issue. 0.8, 1.0, 1.2, 1.4. Yeah, it looks fine. And this is actually 10, but the computer says 9.9999999999996, whatever. So yeah, that's fine. So if we were to substitute, let's copy and paste. Copy, paste. Instead of range, we're going to use my range. And this is going to be my range. Let's see, my range, shift enter. So partial sums, 1 to 10 in steps of 1, works great. 0 to 10 in steps of 0.5. So let's see if that works. So if we have my range from 0 to 10 in steps of 0.5, if we add up this entire thing, my range 0, 10, 0.5. Yes, that works beautifully. 105.0 and this is 105.0. Terrific. So yeah, this time the partial sums function is working just fine, and it does accept a float value. It does accept a decimal value for the third argument. It does accept a decimal value or a float value for the third argument. Chachki, just hold on. We'll go outside soon, okay? Sorry, guys. I'm just talking to my dog here. It does accept a float value for the third argument. Okay, whereas before it did not, right? There was an issue with that. So if I have, partial sums 0 to 3 and steps of 0.2, for example, what is that going to look like? Okay, so what that's going to look like, well, instead of 0.2, let's choose, I don't know, let's choose 0, well, we can choose 1.5. Let's choose 1.5. So that's easy. So 0, 1.5, and then 3. So 0, we start with 0. 0 plus 1.5 is 1.5. And then 1.5 plus 3 is 4.5. That makes sense. And then what if we go up to 4? Or let's go up to 4.5. Okay, so same idea. So we're going to have 0 and then 1.5 and then 3 and then 4.5. So this is going to be 0. 0 plus 1.5 is 1.5. 1.5 plus 3 is 4.5. And then 4.5 plus 4.5, oops, gives me 9.0. So this time I just went to the added trouble. Of making sure that the step variable, the third argument of the function, could be a float. Normally, guys, in these problems, it isn't. It's usually an integer, but I wanted to make this problem a little more challenging, and I wanted to define, excuse me, I wanted to define a function that would accept a floating point value as the third argument to the function. So finally we did figure it out, but in order to do it, I had to create my own range function that I call my range. All right, so that's how you would do it in Python. So very quickly, let me see, what time do we have? Okay, this video is getting kind of long here. Oh God, it's over an hour. Okay, so we're getting a little long here, but very quickly, guys, let me just show you, quit Safari. Hold on one second. Let me show you one possible way to do this using Racket. Okay, and I just want to, here, let me get rid of that. I don't need that. Untitled.ipynb. Okay, and then we can, okay, so one possibility, yeah, this video is a little longer than I expected, but okay, that's fine. So a comment, actually now I'm trying to remember. So a multi-line comment, okay. Okay, why am I forgetting this? So a multi-line comment would look like this. Actually, this is a, here, hold on one second. This is a multi-line comment in Racket. This is a multi-line comment in Racket. Okay, now for the single line comment, let me try to, semicolons. Semicolons. So this is a single line comment in Racket. This is a multi-line comment in Racket. You can write as many lines here as you like. The purpose of this is to help document your program so that you can understand the code that you wrote when you open up your source code long after having written it. This also benefits other programmers as well. Okay, so this is a multi-line comment. This is a single line comment, okay? So there we go. So very quickly, guys, I'm going to try to be quick about this because this video is dreadfully long. Okay, so how would we do this in Racket? Let's see. So you could build for list I, oops, no commas. For list I range 1 to 11 I. So that's going to give you the list, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Now, some people have a real issue with Racket. And by the way, this is similar to Python. Notice you don't actually go up to 11, you go up to 10. You don't go up to 11, you go up to 10, which is just like with a Python range. Now, some people have a real problem with Racket because it uses a million parentheses. So instead of 2 plus 2, here, let me do it down here. Instead of 2 plus 2, which doesn't make any sense in Racket, you would do plus 2, 2, 2, 2. Okay, so what is that? That's 8. Okay, 3 divided by 1.5, that's 2. Okay, so a lot of people have issues with that. It's actually kind of cool. Racket is a Lisp language. So Racket is to Lisp what Python is to C. Racket is like the Python of the Lisp programming language world, okay? And it is kind of interesting. Some of it's challenging, but it's not that dreadful. So what we could do here, let me think for a moment. Okay, we're going to define a function up here. Partial sums. And in Racket, it is okay to name your functions and variables with hyphens. You can use hyphens in your variable names, your identifier names, your function names. Not in Python, and definitely not in Python, and definitely not in Mathematica. That's not going to work, okay? Partial sums, I'm going to put the actually, let me put this, I'm going to call this helper. So accumulator, the accum, and then we're going to do start and stop. And let's just assume the step is equal to 1. Let's just assume, actually, yeah, let's just assume that the step is equal to 1, okay? Yeah, let's just keep it simple because we are running out of time. So if start is greater than stop, okay, let's return the reverse of the accumulator. Otherwise, okay, what's going on over here? Okay, otherwise, let's see, we are going to return, and you don't use the actual word return, partial sums helper, cons, I know it's hard to explain this one, but cons, what does cons do? Cons 3, empty list. Cons 4, 3, 2, 1. That gives me the list 4, 3, 2, 1. Okay. And this is your empty list. Right, that's the empty list, or that's the empty list, or that's the empty list. So cons, okay, cons accumulator, accum plus start, one plus start, and then stop. Let me see if this is going to work. Run, I think it should. Partial sums helper. Of course, the accumulator has to be the empty list. I can just type null, okay. Accum and start, I believe, should be the same number, actually. So they should really be the same number, and then stop. Okay, so escape P, almost, but not quite. How about start is accum. Okay, this is almost what I want, but it's not 100%. Hold on one second. Hold on one second. Well, this part needs to be fixed over here. If start is greater than stop, reverse cons accumulator. Okay, so that needs to get fixed. So partial sums helper, of course the accumulator, is the empty list. Cum is, let's say, 0, start is, let's say, 0, stop is, let's say, 10. Again, this works, except it does basically work, but I have that extra 0 there that I don't really want. So if we have the start of 1, that looks better. Okay, so 0 plus 1 is 1, 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, 10 plus 5 is 15, 15 plus 6 is 21, 21 plus 7 is 28, 21 plus 8 is 36, 36 plus 9 is 45, and 45 plus 10 is 55. The only thing that is a little annoying, oh, you know what I should be doing here? If I really want the behavior that I want, hold on one second. And then I don't think, okay, hold on one second. Accumulator. Okay, let's run this. Let's run this. So partial sums helper. We start, okay, the accumulator is the empty list. Okay, initially accum really should be 0. Start with 1, end with 10. That is perfect. That is exactly what I want. That is exactly what I want. So, and here we're just assuming a step size of 1. The step size is going to be 1. Let's not change the step size, because then the problem gets a lot more complicated. So partial sums helper, we always start with the empty list for this problem. The accum is always going to have to be 0. You start with 0, okay? 10 to 20. 10, so we start with 10. 10 plus 11 is 21. 21 plus 12 is 33. 33 plus 13, we're going to have 46. And 46 plus 14 gives us 60, and 60 plus 15 gives us 75. 75 plus 16 gives us 91, and 91 plus 17, we're going to end up with 108. Yeah, that's 108, and then 108 plus 18. So, I mean, it's working just fine. It's working terrific. Now, what we could do, because every time I use this function, right, I have to type in null, zero, null, zero, null, zero. I mean, it's kind of annoying, right? And it's just kind of annoying. So why don't I do this? Define partial sums to be, and I could do it on this line, curry null, zero. So what does curry do? Curry simply means that I'm providing the first couple of arguments. One second. Wait. Curry partial sums helper null, zero, which means I'm always going to provide null and zero as the first two arguments to my function. That's what curry actually means. So now partial sums 1 to 10. So I don't have to type partial sums helper null, zero, because I'm going to keep typing null, zero over and over and over again every time I use my function, which is kind of, a waste of effort. Because we assume that, the accumulator is always going to be the null list, and accum is always going to be zero. This is always going to be the null list or empty list, and this is always going to be zero, plain and simple. So what is there to worry about? So partial sums helper, null, 0, 1, 10. Why not just type partial sums 110? Partial sums 100. Okay, or if you don't want to see everything displayed vertically like that, you could do display ln partial sums 100. Okay, and just like before. So all the integers from 1 to 100, if you add them up, you're going to get 5,050. And that's exactly the same answer that we had in Mathematica, and that's exactly the same answer that we had in Python. So Racket is actually a very cool language. Racket is a very cool language. I know a lot of you guys are probably thinking, oh my God, this is crazy. Racket is so hard. But let me tell you something. For certain things, Racket is actually much more powerful than Python. Okay, and much more, well, for certain things, it is also more powerful than Mathematica. And I'll tell you this, with recursion, with respect to recursion, Racket is definitely superior to Python. There's no argument about that. There is no argument about that. All right, so, and it's also, I believe, Racket executes its code faster than Python does. Python is actually kind of slow. As programming languages go, Python is a little on the slow side, okay? Racket is a little faster. So do not underestimate Racket. I know some of you are thinking, oh God, this programming language looks crazy. Look at all those, crazy parentheses and this and that. But I'm telling you, this is a good language. It is a good language. It's not a very popular language, but so what? I mean, McDonald's hamburgers are very popular. Everybody loves McDonald's hamburgers. Does that mean McDonald's hamburgers are good? Probably not. I mean, those are not high quality, top quality hamburgers. It's kind of like, if you're hungry, I mean, McDonald's is okay, right? I mean, it's not bad food, but I mean, I don't think you should eat it every single day, right? So, it's the same thing here. I know Python is very popular. A lot of people love it. But that doesn't mean it's the greatest programming language in the world. It's very popular. A lot of people use it, but there are programming languages out there that actually have, there are programming languages out there that pack a much stronger punch than Python, but they are also harder to learn, and that's why I think a lot of people don't like them. But there are programming languages out there that pack a much harder punch than Python. Python is not the supreme programming language in the world, although some people think it is. All right, so I guess we're good. We'll do one more of these. So display ln partial sums 1 to 1,000. Okay, so yeah, good stuff. This is definitely good stuff. And remember, guys, Racket uses prefix notation. So if I want to multiply numbers, right, this is what I have to do, right? This is how you multiply numbers in Racket. You don't do 1 times 2 times 3 times 4. Okay, that doesn't make any sense to Racket. You have to use prefix notation. Okay, prefix notation. That's how you do it in Racket. Everything in Racket is with prefix notation. The whole language is based on it. All right, so I guess that's it, guys. This video is really long enough. And so yeah, I hope you got something out of it besides a headache and a lot of confusion, okay? So be well, and I will see you, we will communicate soon, okay? Take care and study hard. Bye-bye.